So hello everyone. Day 5 of live stream. Uh, and we're back with more game development learning today. Let's go. Yeah, as you can see, we changed the setup. Right now I'm on Windows because Unreal Engine yesterday actually not yesterday, actually was on Thursday, yeah. It was like frying my MacBook, so I had to change my setup. So I'm still did install the Unreal Engine, but I have the Epic Games launcher already here. So let's install it. Alright. Good, so I'll install the Unreal Engine. This time we'll be able to follow the tutorial correctly. Yesterday I was just watching it and doing nothing. But today it will be better because we'll be able to follow the tutorial and do stuff in the engine directly. So yeah, let me check other stuff here. Yeah, let me just check if the quality of the microphone is good because there was a time where I was doing live stream and the microphone was like very bad. So, all right, let me test it. Okay, apparently the microphone is working correctly, so we're good to go. Yeah, let's wait for the engine to install and then we can start following the tutorial. All right. While this is loading, I'll just do other stuff here. Yeah, so for anyone new here, we're basically start learning Unreal Engine. So I'm a software developer with web development background, but right now my main focus is like building a game by myself. So in order to do this, I'm having to learn Unreal Engine. And yeah, I already started this tutorial right here from Unreal Sensei in the YouTube. And I already watched 1 hour of it. It's like I'm learning some basic stuff about materials, about how to move stuff, how to add elements to the screen. And yeah, it's basically this right now, and pretty happy to learn more about this. I really found the game development something really exciting, you know. But I usually I usually only study web development, so studying something different this time, it's really cool. Yeah, I don't know. It looks like it's not installing. It's stopped on, but I think it is because it's like 31% of progress here. Okay, apparently it's installing. Yeah, that's good. Okay, so we are like more than half progress here. I already did some stuff here that I needed to do. Now I believe it's time. Yeah. All right, so now it's time for us to watch a little bit more of the tutorial. Okay, so let me just do something quickly here. Right, so let's continue with the tutorial. The main focus for today is to go for from 1 hour to, I think, 2 hours is good. Yeah, so today is like, today's Thursday, so yeah, my plan was to finish this finish all this tutorial this week. I don't know if it will be possible. Maybe I have to like tomorrow or on Saturday watch a lot of content. But anyways, let's go back here to the tutorial. Let me just activate the theater mode.
Now, I switch to in real time completely change the way our material looks.
Yeah, here he's explaining about material parameters. It's really useful when you want to update something really quickly without having to, go to the material, edit values, and then click apply to compile. So this material instance, I'm explaining so I could also understand better. So yeah, here's explaining about this material instance.
Pretty amazing. Now, I prefer the way this material looked like originally, so I can reset all the values to its default value by clicking on the arrow icon. So set that to 0, 1, 0.35.
Yeah,
and set it back to a little bit off green. Now that we know how to create material instances, it's now time to go over master materials. Essentially, a master material is one material to rule them all. So imagine we have a single material, and from this material, a bunch of material instances are created that are very different from each other. These instances can be anything from paint, concrete, wood, pretty much anything you can imagine, and they all share the exact same master material. So I know what I just said sounded a little bit complicated, but it's best to show with an example. We've already done a lot of the work creating a master material, and it's actually m_Spanish payment. So we're going to turn this into a generic material from which we can create multiple materials from. So let's jump back into our map, and within the content drawer, instead of calling this m_Spanish payment, let's right click and go rename and call this one m_master material. Just like that. So let's double click on it, and I want to make this master material.
Yeah, so as far as I understood, it's like master material is the center material, and then you can create like multiple instances of the same material, and they all share the same like parent material.
Feel pretty generic. So I want all my parameters to have the default values, where if I didn't edit any of them, it would basically be the same as if we plugged in all 3 of these textures without any of those edits. So down here, normal flatness won't make any edits or changes to the normal map, which is what we want. Normal.
Yeah, so just a reminder here quickly, this normal flatness is, we have this function here and we plug this in. This is a parameter, and it's saying like how much you want the normal map to affect the texture. So the normal will add some depth, will add like shadows and stuff to create that feeling of having like a real material. And this normal flatness is the value that defines like how much depth we want to add to the material.
Normal strength is right now set to 1, which will not change the roughness map or make it more rough or more shiny. Also, I noticed I misspelled strength, so let's go fix that. And up here, color tint isn't pure white. If it was pure white, then it wouldn't edit the base color, but it's an off green right now. So I want to make this pure white. Let's double click on this, and I can do so by grabbing the saturation and bring it.
Yeah, I'll just check some stuff here quickly, but I'll be back soon.
All the way down like that. So now we have 1 1 1, and make sure your tint was pure. Go fix that. And up here, color tint isn't pure white. If it was pure white, then it wouldn't. Normal flatness won't make any edits or changes to the normal map, which is what we want. Normal strength is right now set to 1, which will not change the roughness map or make it more rough or more shiny. Also, I noticed I misspelled strength, so let's go fix that. And up here, color tint isn't pure white. If it was pure white, then it wouldn't edit the base color, but it's an off green right now. So I want to make this pure white. Let's double click on this, and I can do so by grabbing the saturation and bringing it all the way down like that. So now we have 1 1 1, and make sure your value right here is all the way up to the top like that. Now we have pure white, which isn't making any edits to the base color. Now we are making an edit to the multiply node right here. So this is a size of 0.35, so it's going to decrease the tiling and make our texture a lot bigger than what it would be by default. So I would need to set this to its default of 1 right there. So let's press apply. And as a reminder, if I open up mi_Spanish payments, essentially by changing the values within the master material in a material instance, we see size right here is 0.35. To change it to its default, all you have to do is click on the arrow like that. So for color tint, it's right now green, which is what it was originally. If I click on the arrow, now it's pure white. So let's go back, and I also want to expose the textures right here. So I want to be able to swap out each of these textures on the material instance. To do so, you can probably guess, of course we're going to right click and go to convert to parameter. Call this one a color, right click right here, roughness, and right click, convert to parameter, normal. So let's press apply, and now we get access to all those textures right here. So if I just turn and activate all of these, I can switch out any of these textures for something else. For example, I can switch it out with grass, and now we have grass as our base color, but our roughness is still using the Spanish pavement and the normal map. So I'm going to press Ctrl and Z to get rid of that. But you can imagine that if we did have a normal map for grass and a roughness for grass, that I could just swap it out really quickly. And instead of it being a Spanish pavement, it is now grass.
Oh, yeah. I think I understand like why this is useful. You're creating basically an easy way for you to just, instead of having to recreate every time a new material and set up, normal and set up like parameters for this, you could just like create a master material, and then from this master material you can generate like all the other materials that you need using like same parameters and same logic.
Master material isn't complete yet. It is missing one function, and that is allowing for metallic maps. Since our Spanish pavement right now isn't metallic, but what if we did have a metallic material and we want to use our master material? Unfortunately, there is no place that we can put a metallic map. So let's jump into m_master material and let's add that right here. So we're just going to duplicate the roughness map. So press Ctrl C, Ctrl V, because just like the roughness map, the metallic map is a mask that shows where in the texture the material should be metallic. And instead of calling it roughness, call this one metallic. Drag it up right here. That's why I was using the same UVs, and simply plug this into metallic. Now we do have the issue, and that is now even a material like our Spanish pavement, which is a metallic, will have metallic values by default, which is something we don't want. So we want the ability to be able to turn on and off this metallic
maybe
map
in this case we could use a multiply, right? I believe that's the solution. Probably, let's see.
So let's jump into m_master material, and we could give ourselves a toggle for this with the static switch parameter.
Oh,
and
it's
select
a toggle.
it right there. So let's call this one.
But yeah, I believe that's because when you have like this is a UV map, right? I don't know what the name, but when you have it scales of gray, with these gray scales, you could set like values from 0 to 1 of how metallic we want that specific part to be. So I believe that's the case. You know, if you want like 1 of metallic, then you have all black here. And then if you have 0 metallic, then it's white, you know?
Is metallic. And
yeah, so this toggle is basically like, should we apply metallic stuff to this? So yeah, that makes sense also. Yeah, I'm willing to finish this because I want to do a little experiments with materials, but yeah, it's 7 gigabytes. It's almost 8, so 80% of progress here.
And then if it is, then we're gonna use the metallic map. But if it's not, we're gonna use the default value of metallic, which is just 0. But if it's not, we're going to use the default value of metallic, which is just 0. So hold down 1 and left click to bring in a constant scalar value. And by default, it is 0. So plug it up like this. And now we have a nice switch where, let's say, for example, if we do have a metallic material, all we have to do in the material instance is check is metallic to true and drag in that metallic map right here. But if I turn it off, then it gets rid of that metallic map. So let me go make some adjustments to
yeah, this is interesting.
Bring down the size. Also, it's a little bit too reflective right now. So I'm going to increase the roughness strength just a little bit to make it a little bit less shiny. And now we have a pretty versatile master material that we can use for a whole range of different scenarios. And we're going to use this master material in the next chapter. Now that we can import textures and have a master material, let's go over how we can import 3D objects and bring them into Unreal Engine. And it's very important to know that in Unreal Engine, 3D objects are called static meshes. And static meshes by itself are just a collection of vertices and faces in space. If you want to change the way that object looks, then we need to add on a material, and generally this material is comprised of multiple textures. So to break down how a 3D asset is constructed in Unreal Engine, first we have our static mesh, which is a plain 3D object. And then to change the way that static mesh looks, we need to add a material. And this material can be comprised of multiple textures. So to better get a sense of how 3D assets are made, let's create our multiple textures.
So static mesh is like the object, the 3D object. Material is like the texture applied to the object. And then this texture, we have the base color, the roughness, that's like how shiny each part of the object is. Normal map, that's to apply depth the to the object, and then the metallic to show, like for example here you can see that yeah, so actually black is 0, right? So this is like a wood box, so black will be 0, so no metallic. We have some dots of white here, so metallic, but most of it, it's not metallic. So yeah, I think it makes sense.
So to better get a sense of how 3D assets are made, let's create our own 3D asset in Unreal Engine. The 3D object we're going to be importing into Unreal Engine right now is included within the beginner assets. So double click to open this up, and it's the woodcrate.fbx. So we're going to import this into Unreal Engine. If I double click on it to see what this 3D model is, we can see that it's just a very simple crate. So nothing too fancy, but it will get the point across on how we create 3D assets in Unreal Engine. So let's go into content drawer, and under my stuff, I'm going to save everything, right click, let's create a brand new folder, call this one wooden crate. Let's double click to go inside of it. So wooden crate will have all our assets that combine to create the wooden crate asset. So first, let's import the 3D model. So hold down left mouse button, drag it, and simply let go. Now we have a bunch of FBX import options. Generally, I keep it at default. If you do see something is different, click on reset the default to get those default values back. Now, generally under material, for create new materials, I do not create a material. Since we are not going to be starting from scratch, we're going to be using the master material on this. And for import textures, check that to false since we aren't going to be importing any textures, since I'd rather import those textures manually, and click on import. So we might get this warning, that's fine, you can ignore that. And now if I double click on the wood crate, we can see that our wooden crate has been successfully imported into Unreal Engine 5. I can drag this out into my scene, scale it, rotate it, move it around. Pretty much it has all the same functionalities as any of the objects that Unreal Engine comes with. So that's how you import a 3D object. Let's go over how we can create a material for this 3D object. Now, luckily for us, we've already done most of the work, and that is our master material. So m_master material has everything that we need to create a material for this object, except the textures. So let's import the textures real quickly. Press Ctrl and space to bring up the content drawer. Select all of them with Shift and drag them into the content drawer. So let's double check that all our maps are correct, starting with the base color, and sRGB is turned on, which is exactly what we want. Wood crate underscore metallic should have sRGB turned off since this is a mask.
Yeah, let's go back.
This fancy texture right here we are going to ignore, but I will go over it in just a bit. And right there is wood crate underscore normal. Let's double click, make sure that it was imported as a normal map. sRGB is turned off, and compression settings is set to normal map, which is exactly what we want. And for roughness, of course, since this is a roughness mask, make sure sRGB is turned off. So let's go save everything and create a material instance of our master material. So let's right click, create material instance, and call this one mi_wooden crate. So drag this into our wooden crate folder and move here. So double click, and we have our material instance. So I'm going to apply this to our crate, and obviously it's using the wrong textures. So let's open up our material instance for wooden crate and activate color, normal, and roughness. So let's drag those textures that we want, specifically color into base color, roughness into roughness, and normal into normal. Our material is almost complete, but we are missing one last thing, and that is the metallic map to make our nails metallic. So to do so, this is why we added the is metallic switch right here. And now we get the metallic texture. Let's turn this on, find where our metallic map is, and simply drag it onto texture and let go like that. And now our nails are metallic. We can see it successfully reflecting the sun. So that's pretty amazing how very quickly we were able to automate the process of creating a material by using our master material.
Yeah, so yeah, the only problem is like creating these assets by yourself, you know, and that's something that we will learn in the next weeks. So probably on Blender, we'll learn how to create these normal maps, this other maps for metallic, roughness, you know. So yeah, but it's a lot for like a solo game developer, you know. I know that we also have some Reddit stuff, you know. We have like mag scans But I feel like Megascans is like for realistic games, you know? And when you want to have something more, with a unique style, then you probably need to build stuff by yourself. And that's the difficult part, but anyways.
So we could create a material without ever even touching the material graph by just creating an instance of that master material. And what's amazing is that we still have access to all the parameters right here. So I can change the normal flatness to -5 to increase the normals, or I can go into roughness strength and decrease the roughness value to make our box even shinier. I can even go into color tint and give it a slightly orangey reddish tint. Now it is important that if you do drag a texture onto an object and the texture looks like this, so it looks completely out of sync, that's because the size value most likely is not 1. So come into size and make sure that it's set to 1 as its default value. So now we have a nice box asset. I can hold on Alt, duplicate this, maybe scale it up, and even drag it from the content browser. But now we do have an issue, and that is when we drag a box from the content browser, it does not have the material we just created. So to set our box's default material, we need to open up the asset static mesh editor. And within here, we see that we have a default material slot. Right now it's using the world grid material. We're gonna set this to mi_wooden like that, press save. And now that material is applied to all our boxes, even when we drag out a brand new box. Before we move on to the next chapter, I think it's important to point out what this texture right here does. So I'm gonna double click on it, and this texture does look a little bit weird, but essentially what it is that it combines several different masks into one texture using the RGB channels. I know that might sound confusing, but essentially in computer graphics, color is made up of a red channel, a green channel, and a blue channel. So what developers realize is that they can take these individual channels and then hide masks inside of them. So for example, if we uncheck the blue channel and the green channel, we see that the red channel of this texture is our metallic mask. Uncheck red, check green, our green channel is roughness, uncheck green, and check blue. Our blue channel is ambient occlusion, although we won't use it.
Right, so it's one image, we have everything combined. Like for each channel, like R channel, G channel, B channel, each one contains a different information. That's really interesting.
Use ambient occlusion. I included it within a texture to show that we can hide 3 different masks inside a single texture. And because even though this is a color texture, it's actually going to be used as masks, we want to uncheck sRGB right there. So the way we would use this in a material is let's create a brand new material, call this one mask example, and double click to go inside of it. So if we were to create a material from this mask, I'm going to drag out our base color in our normal map, because of course we still need them. And instead of using our metallic or our roughness texture, we combine those into one individual texture right here. So we don't need those since they're combined into this one. And
and then you connect the red channel to the corresponding texture that you want to apply. That's really genius.
Metallic, so I'm gonna grab from the R pin.
That's
metallic,
like mind-blowing.
Green channel is roughness. Now roughness didn't have to be the green channel, it could have been blue or red, just I decided to use the green channel. And if I press apply, inside of our map, let's apply the new material to this crate. And right now there is a slight difference between the two, since in the material instance I am using color tint.
Yeah,
so reset that back to white, and jumping back here we can see that there's virtually no difference in between combining the textures or using the textures separately. So I included it within this course because it's pretty important to know why Unreal developers use this, since you will be seeing this a lot. Also, it's good to know exactly what these R, G, and B pins are used for. That is how you create Unreal assets, but you're probably wondering now, how do I move Unreal assets in between different Unreal projects? Because it would be a real shame if every time we create a new project, we have to remake all the assets. and we can move assets in between projects through an easy process called migration. So
Okay, so before learning how to migrate materials, right now I have to do a small pause for lunch. So yeah, I'll be back in about I don't know, 40 minutes. Yeah, probably. So yeah, do a small pause for lunch. I'll be back soon.
mais rápido e eficiente de escalar suas vendas já existe, e ele envolve.
Right, we're back. Yeah, let me just get some stuff here. Oh, right. Okay, so let's go. Yeah, I gotta sew some stuff here, some other stuff, and then I'll be back to the tutorial. Alright, so apparently the Unreal Engine installation is finished. So time to open it. Let's go. Let me fix this. Alright, let's start. Yeah, I think that differently from MacBook, I think that my PC will be able to handle your engine. I hope so. Alright. Okay, let me oh, my IP address here. I think this is fine. I hope so. Please don't hack me, guys. Okay, new project. Yeah, here we only have the blueprint option. Why don't we have like the C++ option here? Oh wait, I have to, yeah, someone is calling me, wait a second. Alright, I was solving some stuff, but we're back. So yeah, as I was saying, well, we finished downloading the Unreal Engine. Let me, I don't know, maybe like this. Maybe this is too small, but that's good. Let's start a new project here. We want to go into games, blank project. Oh, all right, that makes sense. And the blank, then we have the C++ or Blueprint. Then we can choose the platform, the quality, maximum quality is fine. Let me call this first project. It's in documents or your projects, that's fine. Let me create. And we're starting. Look at this. I believe that this will load like much faster compared to the MacBook. The MacBook took like, I don't know, 5 to 10 minutes to open for the first time. Because this shaders compilation, it takes like a lot of time. Lots of time. All right, so while we are loading this, let's keep watching the tutorial, right? Let me just check some stuff really quickly here. This time it's quickly. Fire. Oh, this looks good. This looks really good. I just have some stuff to fix here that I believe it will be better to fix. All right, let's continue here.
Between two Unreal projects, of course, we need a new Unreal project. Included within the downloadable content, link in the description below, is a project that contains some assets I want to bring into our first project that we've been working on. So within the zip file, go into it, and it's specifically Intro Unreal Project. So just drag it onto our desktop to unzip it, and double click to go inside of the project folder. To open up an Unreal project, double click on the .u project. Now that I have the downloaded project open up, if I press Ctrl and space, we can see all the content that's currently inside of it. Now, if your content folder is empty, then that means you didn't unzip the project. So make sure you do unzip the project before opening it up. So I have a folder called Lighting Examples with some maps, materials, meshes, and textures that are going to help us demonstrate Unreal's lighting capabilities. I don't want to bring all of these assets into our original project called First Project. So to do so, I'm going to dock them to the sides of my screen, and let's go open up our content drawer. So what I'm going to do is copy our lighting examples folder, which is right here, and bring it into another project. To do so, we use a process called migration, and migration is really simple. Simply hover over the assets you want to bring into another Unreal project, right click, and select migrate. Now it's going to give us a list of all the assets that are going to be migrated, and this all looks correct. So I'm going to click on OK. And now it's asking for a location to migrate them to. We specifically want to migrate them into the content folder of the destination project. And you can find out where the content folder is by double clicking on the original project file. So right here is First Project, which is where this project is stored. And if I go into its project file, we see that there's a content folder, and this is the location that I want to migrate all these assets to. So I could go through and manually navigate to this location, or I can copy its destination with Control C and Control V it right here. So now I have the content folder of our original project selected. I'm telling Unreal that I want to move the files from Unreal
it's not that difficult
to first project, and click on select folder. So now we can see content migration successful. And if I go into first project now, press Control and space, under content, we now have lighting examples, which are all the same assets from our downloaded project. Now an alternative, that's so we don't have to go and find where our project file is located. In order to get the content folder's location, I could press Control and space to go into the content drawer and right click on our content folder and go show and explore. This will automatically bring up the content folder from our project. Finally, let's talk about Unreal Engine 5's brand new lighting system called Lumen. And Lumen is revolutionary because it gives us real-time global illumination.
Oh yeah, that's pretty cool. I remember, I believe the first time you open the Unreal Engine, it would take a lot of time for both the MacBook and Windows. I thought it was a MacBook problem, but apparently it's not.
And essentially, global illumination is just a very fancy term for light bounce. Because in real life, light doesn't just hit an object and stop. Instead, it hits an object, bounces off that object, and after each bounce, it illuminates the world. It also takes a little bit of that object's color and projects it onto the next object. For example, it might be a little bit hard to see because the video is being streamed, but here we have a red mouse, and light is hitting this mouse, taking a little bit of its color, and then projecting it onto any nearby objects. So if I move the mouse to the table, around the table, there's a little bit of a reddish tint that's coming from the bounce lighting. So global illumination is important because it's the secret to realistic rendering. But there's one large problem, and that is global illumination is very expensive to calculate. Real-time global illumination isn't possible without a super powerful GPU. And this is where Lumen comes in handy. Lumen is a brand new way to render global illumination at the fraction of the cost.
Look at this. Finally, we have it working, guys. Let me expand it here. I think this is good. Maybe like this. But anyways, look at this. Now we finally have the Unreal Engine here. We have, let me have controls. We have navigation. Yeah. We could increase the speed. I think it's here. Yeah, here we can increase the speed. Look at this. So cool, right? But how do I look up? I just forget how to do it. Yeah, I don't know how to look up, guys. I know how to go down and up. Yeah, but anyway, this is
compared
fine.
to traditional ways to get global illumination, like hardware ray tracing. So to show Lumen in action, let's jump back into Unreal. And to do so, we need the content that we just migrated over. So if you haven't already, make sure you download the lighting examples, link in the description below, and migrate it into our project from the previous chapter. So to begin, let's go to Maps and Light Bounce. So
Oh, right. Let's skip watching here. This Lumen would be like the interesting part of the tutorial, I think. Because illumination is something so important in games, you know, to create the atmosphere, to create like lighting and all of this stuff, and also being able to uh I want to change the language here. I want to put it on English. Yeah, how can I window? Oh, I think it's here. Then English. Okay. It's in English right now. I think we need to. Oh. Okay, it's in English already. That's good.
So as we can see,
Yeah, let's
this is
keep
bounce.
watching here.
So to begin, let's go to maps and light bounce. So as we can see, this is an insanely simple room. All we have is 4 walls and 2 objects and a light source. I've also gone ahead and added in a post-process volume. Since by default Lumen is turned on, I want to turn off Lumen to demonstrate how we used to get global illumination back in the Unreal Engine 4 days. So as we can see, global illumination method is set to none. Now let's just pretend that we're in Unreal Engine 4 and I want some global illumination, since obviously shadows are never this dark. Normally you would see some light bouncing around to illuminate the shadow areas right here. So the first thing I would do is, number 1, make sure my light sources are set to static, not movable. And number 2, I need to build my level. And to build, you want to come up to the build tab all the way up here, select it, and within the drop down, simply select build all levels. Right now behind the scenes, Unreal is ray tracing our entire level and creating a light map. This light map contains all the lighting data, which it then overlays onto our world as a texture. Now we are done building our lighting. It should have been pretty quick because this is a very small level. And if we look at our level, we can see that we do have global illumination.
This is so nice, bro. Look at this. It's so much more like realistic.
Notice how this sphere is no longer pitch black in the shadow areas. There's now light filling up the shadows, making it look a lot more realistic than beforehand. We can even see that there's some red on the sphere that's bouncing from the red wall. Same thing over here. The entire room has a little bit of a greenish tint, since this green wall is also bouncing light off. So this is how we used to get global illumination on Unreal Engine 4, and while this is great, there are some major issues. Mostly that our lighting and all our shadows are static. So if I select my sphere and move it around, we can see that the lighting breaks. Press Ctrl Z to undo that. Then even if I select my light source and move it around, the lighting also breaks. Notice how if I move my light away, we now have 2 shadows. So there's one shadow that's coming from the light source and another shadow that's coming from our light map, which is no good. So I'm press Ctrl and Z to put our lighting back at the original spot. And this is where Lumen comes in really handy, because it allows us to have dynamic global illumination. So I can move my light around and move my sphere with no issues whatsoever. But first, we have to get rid of our light map since we did bake our world. To do so, you need the World Settings tab. Now by default, there is no World Settings tab. We can get that by coming up to Windows and selecting World Settings all the way down here. And now we have our world settings. As you can guess, world settings is simply the settings of our world. So this is where we would control our light baking. And we will go over light baking settings in just a bit, but for now I want to get rid of our light maps by selecting Force No Pre-Computed Lighting, which will tell Unreal that I don't want to use any light maps and I don't want to build our lighting. And then after I set that to true, make sure you press build. Now that didn't build our lighting, instead it went through and it got rid of all of our light map textures. So let's come back to details. And now I'm going to set my light source to movable. So now that it's set to movable, we still aren't getting any global illumination, because if you remember in the post-process volume, I turned off Lumen. So let me zoom in a little bit so that we can see this better. Here is Unreal Engine 5 without Lumen, and here is Unreal Engine 5 with Lumen. So this is without, and this is with. And what's amazing is that I can move this light around and there are no issues. I can even move this sphere and make it bigger, smaller, and Unreal is calculating all this global illumination at a very smooth frame rate. which is absolutely amazing. This was not possible in Unreal Engine 4. So if I grab this light, and even if I move it all the way over here, we can see that there's bounce lighting coming from the light hitting the wall, and then bouncing and hitting the sphere, giving our entire sphere a little bit of a reddish tint on the right side, which is very realistic. We could even come into the point light settings and gives ourselves a softer shadow by increasing the source radius. So if I increase this, notice that the shadows get softer and softer. Global illumination used to be pretty expensive since you'd have to use hardware ray tracing, but now, thanks to Lumen, it's accessible to everyone, while running at a smooth frame rate depending on
Yeah, my question is, yeah, it's accessible, but is this like possible to run in like a mobile? Let me ask ChatGPT. Let me open here. Yeah, I need to plug with Google account. Okay, so in Unreal Engine with Lumen, could actually in Unreal Engine, could I use Lumen illumination in mobile phones, or is it too heavy? Yeah, it's too heavy for current mobile phones. Unreal Engine systems designed for high-end PCs, current-gen consoles, PS5 and Xbox. Yeah, so for mobile phones, no Lumen, guys.
your computer. And something that was not possible in UE4, even with hardware ray tracing, is that if I come into lighting examples, materials, and use m_emissive material, our emissive materials give off light. So I'm able to light up a scene by just using our materials, which is really amazing. So I'm going to press Ctrl and Z to undo those, since now it's time to go over all the different light sources that Unreal Engine has to offer. So to begin, let's talk about the point light. So I'm going to delete it, and to get a point light, you want to come up to the add button, of course, and under lights, drag in a point light. So the point light is the most basic of lights. It's just a point that emits light in all directions. So let's go over the most important settings in the details panel, and probably the most important one right now is intensity. So it's at 8 candelas. I can bring this down to 1, 2, or even something insanely large like 100 to change the power of the light source. But for now, I'm going to leave this at 4. We also have the source radius, which I just went over.
It's so crazy, man. It's like you are building a world. You know, you're configuring stuff. It's insane. That's what I like in game development. You have this freedom, you know, of creating stuff and make it work. That really, I mean, that really makes me feel like this is very, very, very cool.
But if we increase it and make sure that you do have game view turned off up here, you can see that there is and hopefully you can see this a little bit better with the red background. We have the outline of a yellow sphere. And this sphere basically tells us the size of our light emission. And the larger our yellow sphere is, then the more soft our shadows will be. And as I decrease this all the way back down to its default of 0, we get some really harsh shadows. So if we want to soften that up, bring up the source radius. Now right below that, we have temperature. So temperature allows us to change how warm or cold our light source is. If I bring this down, our light source gets warmer and warmer. And if I bring this up, it gets colder and colder. And I can disable temperature by clicking on the temperature button. And all the way down here, we have light color. So as you can guess, light color just changes the color of our light. The controls are exactly the same as our materials. And above all of these is the indirect lighting intensity. So right now it's set at 1. When I set it to 0, we're gonna have very little bounce light, and our shadows end up like beforehand where they're pretty dark. Not much bounce lighting is happening. Or instead of 1, which is its default, I can bring it up to 10, and now we have a lot of bounce lighting. So I'm just gonna leave it at 1 for now. So those were all the main settings for point lights. I'm gonna delete that, and let's go over the next light right now, and that is the spotlight. The spotlight is very similar to the point light, although unlike the point light, the spotlight is just illuminating one direction. And you could change the direction the light is pointing by, of course, rotating it. The settings are the exact same as the point light, except we have an inner and outer cone angle. So the outer cone angle will control the size of our spotlight, and the inner cone angle will control the fall off of our light. So I'm going to go to game view mode so we can better see this. And as I increase the inner cone angle, we can see that our lighting gets sharper and sharper and sharper. And if I decrease it all the way to 0, there's a very soft fall off. So those are the controls for the spotlight. I'm going to delete that and go into the next one. And that is the rectangle light. So rectangle light is pretty similar to the spotlight and directional light, except now we're emitting from a rectangle pointing in a specific direction. Hopefully you can see the outline of the light when it's against the wall. And I control the size of the rectangle by going into source width and increasing the width, or I can increase the height. I can even, just like beforehand, play with the fall off by decreasing the barn door angle from 88 all the way to 0. And hopefully you can better see it from this angle, what the barn door is. Or I can increase the length. So we have a lot of control over the specific fall off of that rectangle light. Other than that, the controls are the same. So let's delete that. And next up is probably the light you're going to be using the most, the directional light. So we don't see anything with the directional light right now because I have to rotate it to see what it does. And as you can guess, this is the sunlight. So the sunlight is pointing in a specific direction infinitely. And just like the spotlight, if I rotate this around, I'm able to control the direction of our sun. The directional light has pretty much the same exact controls as our point light, except if I zoom in on the shadows, we get source angle. Bringing up the source angle makes the shadows smoother, and bringing down the source angle makes the shadows sharper. So I'm going to reset its value by clicking on the arrow icon, and I'm going to delete our directional light since there's one last light I want to show, and that is the skylight. So let's drag in the skylight, and you'll notice nothing is happening. And the reason why is because the skylight is pretty unique. Essentially what it does is that it captures our sky and then it projects it onto our world. And right now our skylight isn't doing anything because obviously our world doesn't have any sky. So the way we can add sky is pretty simple in Unreal Engine 5. You just want to come up to the add button, come all the way down to visual effects, and drag in a sky and atmosphere. Simply place it right there. And again, if I look up, we don't have any sky, since the sky requires a directional light, which is the sunlight. So let's also come up to add, down to lights, and drag in a directional light for our sky. Now, if our skylight isn't working, then it has to be refreshed by going into the details panel and turning on and off effects world. Now, the reason why I know the lighting in our room right now is from the sky and not from the directional light is because the directional light is not hitting the inside of our room. So if I move it around, then we can see that our directional light is illuminating our room. But if I move it, that's how it's coming from the back. The lighting is entirely coming from the skylight. And we can see this better by hiding and unhiding the skylight by using the effects world.
This
right
is
now.
totally,
Here, the skylight is being
yeah,
used,
this is very
and here the
mind-blowing.
skylight isn't. So this is without skylight.
It's a lot of
and this is
information.
with
So
skylight.
yeah, we're like taking here lots and lots of information. The main focus would be to learn what can we do, and then after we will focus on building a project, you know, to consolidate the information we're receiving, because I believe that the only way to really test your knowledge and to really consolidate is to apply and to practice. And also, I want to build X, and to build X, I need to learn. I need to use this concept. I know about lighting. I know to use this other concept. I know about materials. So then, when doing this deliberate practice, this is the way that we consolidate the knowledge.
And something that's pretty cool about the skylight is that if I add in a cube, so let's come up to shapes, cube, drag that in, scale that up, we can make a makeshift door. And now notice how as I move my cube, the skylight slowly starts to illuminate our room. So that's why the skylight is a pretty big deal, since it allows us to capture our sky and project it onto our world as lumen lighting. And finally, it's time to go over lumen settings. So these are settings that affect all of our lumen lighting before we move on to lighting an environment completely from scratch. So I'm going to delete everything, and I'm just going to add in a simple point light once again, because I want to show and also decrease the intensity to 4. And this is probably something you've noticed, is that there is a lot of noise, especially in the shadows. Now, I don't know if it shows up due to the YouTube compression, but if you are following along with the tutorial, you can see a lot of that noise. And to get rid of that noise, we need to play with the lumen settings, which are located in our post-process volume. So find out where your post-process volume is. As a reminder, you can create a post-process volume by coming up to add, volumes, and post-process volume, and make sure in your post-process volume that infinite extent unbound is turned on, because otherwise our post-process volume will not be affecting our entire world. So you want to come down all the way inside the post-process volume to global illumination, and by default lumen is turned on, and we get a bunch of lumen settings under lumen global illumination. So first off, to get rid of that noise, check final gather quality and increase it from 1 to 4. Now we can see that noise slowly start to disappear, and there is a lot less noise. We can even increase this to 10, and now our scene definitely looks a lot better. So if we hover over any of these settings, it gives us a very quick description. While final gather quality does get rid of the noise, it also comes at the cost of GPU. So just keep that in mind, that if you do increase final gather quality, you might lose on some performance. There are also some other settings, which I'm going to go over in the next chapter. That's the basics of lighting in UE5. Now we're going to take the knowledge that we just learned and apply it to lighting an architectural visualization scene. First, we're going to light the environment by using lumen and movable lights. Then we're going to light the same exact environment, but with static and baked lighting. So we're going to compare the two methods of getting global illuminations and see their pros and cons. The specific architectural environment is already included within our lighting examples that we migrated into our first project. We can see under lighting examples maps, it's the map that's right next to the map that we've been editing, which is light bounce. So let's double click on ArcViz room, and we won't see anything because there are no lights. If I press Alt and 3, or if I click on unlit from the view mode, that this environment is just a simple room with some furniture and a window from which all our light is going to come from. So a very simple room, which will help us learn and get the gist of how to light a scene in Unreal Engine. I'm going to press Alt and 4 as a shortcut to go back into our default view mode. Now the first light I'm going to add in is the main light, which is the sun. So let's add in a directional light, and I'm going to rotate it so that the sun is coming through the window. And already, especially right here, we can see global illumination and lumen at work. So I want to find a nice angle. I think right there is pretty good, but if we look outside, there is no sky. It kind of looks scary just seeing an endless black void. So let's add in a sky by coming back up here to visual effects and the sky and atmosphere. So drag that in, but half of our world, the bottom half, is still a black void. We can hide that black void with fog. So come back up to add visual effects, and below sky and atmosphere, we have exponential height fog. Simply drag that in. And now if we look outside the window, all we see is sky, which is what I want. But there is a little bit of an issue, and that is if we hide and unhide the exponential height fog, we can see that there is a little bit of fog inside of our room, and we don't want that. So within the exponential height fog, one of the settings we're going to change is right here, start distance. I'm going to drag this all the way up to its max of 5,000. So essentially start distance is saying, do not use fog until we're 5,000 centimeters away from our camera. So now if I hide and unhide it, we don't have any fog inside our room. There is one more light that I want to add to our room, and that is the skylight. So let's come to lights, skylight, and drag it in. So we can already see that our room got a little bit of a bluish tint from our sky. I can hide and unhide it right here. So effects world, turn it off and turn it back on. So we can see that it does make a little bit of a difference. So I'm going to set the skylight to movable and also set the sun to movable. Since both of these lights are being used with Lumen, we aren't baking any lights. And another thing I'm going to do is add in a post-process volume. Since if we come over here, and I don't know if it's noticeable in the YouTube video, but there is a little bit of noise. So we can get rid of that by adding in the post-process volume. Simply drag it in and make sure you scroll down, and infinite extent unbound is turned on, so we don't have to be in the post-process volume for it to take effect. Now let's zoom all the way up to Lumen Global Illumination, and right here for final gather quality, instead of 1, I'm going to set that to 10, and a lot of that noise just disappeared. Also, I want to add some soft shadows to the really small objects, since right now there is no soft shadow that's being given off from the phone, the clock, or the coffee mug. So the reason why is because I have to increase the lumen scene detail right here from 1 to 4. So this was beforehand at 1, and now this is 4. So by default, to save on processing power, Lumen excludes a lot of small objects from its calculations. So you need to tell Unreal that you want them within the Lumen calculation by increasing it from 1 to 4, or even higher if you do have smaller objects. And one last edit I'm going to make to the post-process volume is setting it for a manual exposure. So under exposure, metering mode, set to manual, bring up the exposure compensation to 13.25. It's pretty good. And also, this is an artistic choice. We increase it, we can see that we get more bloom in our world. So maybe a value of 2. So this is without bloom and with bloom. I do think it makes the scene look a little bit nicer. And that is the basics of lighting and environments in Unreal Engine 5, specifically for architectural visualization. And since we're using Lumen, that gives us the ability with Control and L as a shortcut to rotate our sun, watch our world be updated in real time based off of our sun's lighting, which is pretty insane. Now, while Lumen is amazing, we do get some trade-offs in quality. Just because we are able to use real-time global illumination doesn't mean that it's the best case for certain scenarios, specifically a scenario like this, where there isn't going to be any moving parts since it's just an architectural visualization scene. We might as well bake our lighting because number one, baked lighting is always more performance friendly than using Lumen, because Lumen does do a lot of GPU calculations behind the scenes, while baked lighting is just overlaying a texture. And number two, if you properly bake your lights into a good light map, then the quality will be better than Lumen. So let's convert our Lumen environment into a baked lighting environment. So I want to make a copy of our current level, which is ArcViz Room, by selecting it in our content drawer and pressing Ctrl and D to duplicate it. So let's call this one ArcViz Room Baked, and double click to go inside of it. Make sure we save selected. All right, great. So first thing I'm going to do is select all my lights and set my directional light to static and set my skylight also to static. Now I'm going to go into my post-process volume and disable Lumen for reflections and global illumination. So set this to none, and under reflections, also set this to none. So we can see immediately we aren't getting any global illumination. That's because I should come up to build and build all levels to start ray tracing in the background. All right, great. So here we have our baked lighting. This is really bad since we need to increase the quality of our light bakes by going into the world settings. And if I scroll up, we can see that under light mask, we have light mask settings. And in the dropdown, we have a bunch of settings that will change the quality of our light baking. So first thing, I want to increase the number of bounces, which will just illuminate our scene a little bit more. So the number of indirect lighting bounces is right now set to 3. Let's set that to 10. And also for sky lighting bounces, set this from 1 to 10. Number 2, for static lighting level scale, if we bring this below 1, for example 0.5, then we're going to get a lot more quality out of our bakes. So I'm going to set this, instead of 0.5, let's set this to 0.1. And to compensate for the static lighting level scale, you want to increase the indirect lighting quality to 10. So specifically, I want to increase the indirect lighting quality to 10 because the static lighting level scale right now is set to 0.1. And generally, you want your static lighting level scale times your indirect lighting quality to equal 1. So for example, if instead of static lighting level scale being 0.1, I change it to 0.5, then the indirect lighting quality should be set to 2, since 0.5 times 2 equals 1. But I'm going to leave it at 0.1 since that does give us a better value at the cost of waiting a little bit more for the ray trace calculations to happen. And now that I like my settings, come to build and click on build all levels. So this build will take longer than beforehand because we increase the quality of our light bakes. So now this is our scene, and we didn't really notice that much of a difference since I also want to come up to build and under lighting quality, make sure that it's not set to preview. Instead, it's set to either medium, higher production. I'm just going to set to medium. And also while I'm at it, I'm going to select my post-process volume.
Yeah, I just noticed that it's a lot of configuration that you need to do for yourself. Look at how many options we have for each different object when we interact with. So it's just, you cannot just, learn anything and just decorate everything that Unreal does. You need to learn in practicing. So that's why for this week we have a small project that I'll be building, and I'll try to use like all the concepts that I learned here.
And let's bring down the bloom, since I think the bloom is too intense, to 1. And for exposure compensation, I'm going to leave it at, let's go 12.7. And now if I press build all levels, keep in mind that if you are following along exactly with this tutorial, you do not have to press build whenever I press build, since I'm building my lights a lot more frequently than I would to just demonstrate what some of these settings do. So if you want to save time and not have to wait for each build, then I would wait for the very end and copy those settings. We can see that the quality is still not the best, because if you remember, light maps are being baked into a texture, and if that texture has low resolution, then we're going to get low resolution shadows and lighting. So we need to raise the resolution on each of our static meshes. And to see the resolution of our static mesh visually, you can come up to lit, down to optimization view modes, and select light map density with the shortcut Alt and 0. So right now our entire room is pretty much blue. This is not what we want. We want our scene to be in the greenish to reddish range. So to increase the light map resolution of a static mesh, you want to select the object, and within the details panel, scroll down until you see lighting and overridden light map resolution.
Oh yeah, so why the quality of the illumination was bad? You can see that when you have a higher number of polygons, like these objects here, that is very detailed, you need lots of triangles and vertices and stuff. It's red. Green, it means that that's on some level. Blue is like this it's one that's like I mean, look at this. This is a square, right? You don't need that much number of polygons to represent this in a 3D world, But then the problem is we have a map for lighting, and then the map for lighting is utilizing this pattern here. So if you want to draw the lighting, it will draw using the quality, it will draw using the resolution that we have here. So we will use like you can see that we have a large square here, larger squares here. So like once you paint something, you paint on the squares, and the final quality will be very bad. So that's why we will increase this. So we have better quality on this area here. You know.
64, turn that on, and increase that to, let's try 128 or 256. And okay, that looks a little bit better, but since this is the floor and it will have some of the shadow, I want to increase that to 512.
Yeah.
So
oh,
make the floor pretty.
Yeah, another thing. It's changing only the floor because the light of the window is going on the floor, so you notice it better. But in places where this doesn't apply, you don't have like much things going on. We can keep the like the normal resolution, so you can save up calculations. You know.
Pretty dense. I think the walls around it should all.
And I'm explaining here, you know, but I'm learning it too, so I'm not 100% sure everything that I say here is just my way of understanding what's happening. And I believe that makes sense.
Also be, let's go 512, and the roof can also be 512. So for the baseboard, I'm going to select that and make this.
Oh yeah, he's changing everything.
Let's try 256. The door needs to increase it from 64 to 128. The chair is a pretty big deal since it's our focal element. So let's go 256 right there. And for the wall, is at 256. I'm gonna try 512. The table is at 128. Actually, let's make this 512. The wall right here, 512, and the floor. Actually, I'm gonna increase this to 124. So I think this looks good.
Yeah, so
Now if we bake our lights, let's see what this gives us. So at this point, it is gonna take a little while for our lights to bake, since there's a lot more detail it needs to calculate. And probably by now you understand why Lumen is a pretty big deal, since it gets rid of this repetitive process of having to wait for our lighting to bake, and then if we don't like the bake, we have to change something and change some settings and then bake our lighting again. And then if we don't like that, we have to go back, and it's an entire process, while Lumen just works immediately. But in this case, it is worth it since the quality is going to be better than Lumen. Okay, now that we're done baking, let's see what our world looks like. And okay, that's a lot better. But the shadows, especially in between objects, are a little bit too intense, since by default Unreal is calculating ambient occlusion. I want to disable ambient occlusion since I'm just relying on our baked light map to simulate all of our shadows and lighting. So within our post-process volume, let's go find where ambient occlusion is, which is right here under rendering features, under ambient occlusion, intensity. Let's turn that to 0 to turn it all off, and increase our exposure compensation to 13. Okay, now our scene is baked, but we are missing one last thing, and that is we don't have any reflections whatsoever. Our world looks pretty bad since we don't have those reflections. And the reason why is because Lumen calculates reflections automatically. When we bake our lighting, we have to specify where we want our reflections to be. And we do that through a sphere reflection capture. So to add a sphere reflection capture, come up to the add button, down to visual effects, and drag in a sphere reflection capture. Essentially what the sphere reflection capture does is that it drags
Wait. I need you.
world, and that is we don't have any reflections whatsoever. Our world looks pretty bad since we don't have those reflections. And the reason why is because Lumen calculates reflections automatically. When we bake our lighting, we have to specify where we want our reflections to be. And we do that through a sphere reflection capture. So to add a sphere reflection capture, come up to the add button, down to visual effects, and drag in a sphere reflection capture. Essentially what the sphere reflection capture does is that it takes a 360-degree snapshot from the sphere of our world, and then it uses that as the projection of our reflections. And to get a better snapshot of our world, come up to build and select build reflection captures. So right now we have one reflection capture, but we can have multiple reflection captures, since obviously it doesn't make sense for all reflections to grab from the same location. So if I duplicate this with Alt, and then if I decrease the influence radius within the details panel to, let's go 500, and place it on top of my small objects right here. And once again, come up to build and build reflection captures. We can see that these objects, instead of grabbing from this sphere reflection capture, they're grabbing from the smaller one, which is overriding the larger one. Since the reflection capture on the table is smaller, Unreal knows to pick this sphere reflection capture for all the objects within its radius of 500 centimeters. So this is essentially how you bake lighting in Unreal Engine. Now I know that the setup took a lot longer than using Lumen. Also, we have to wait a while for each light baking to happen and for all the light maps to be created and the ray tracing to happen. But in the end, in my opinion, the quality, especially right here, if I select the chair and hide it, we can see how detailed those soft shadows are. And if I unhide it, take a good look at this baked lighting scene, jump back into our ArcViz room, which is using Lumen. Obviously, the baked lighting looks a lot better. So hopefully you understand the difference between baked lighting and Lumen, their pros and cons, and why you would use baked lighting over Lumen, even though Lumen is real time. That is the very basic use. Hopefully you're using Lumen scene, jump the baked lighting. Why? That is an entire art of lighting in Lumen, even though Lumen is real time. That is the very basics of lighting in Unreal Engine. Of course, you could get even more complicated because the lighting is an entire art form by itself. But hopefully you do have a good foundation to learn more. Now we're gonna go over.
All right, yeah, this is the main focus for this week. I mean, I just want you to learn the very, very basics from like every aspect about utilizing the engine. So this is good. I think I'll be wrapping for today, guys. Yeah, we almost did 2 hours of the tutorial. We didn't mess up with anything here. Yeah, that's a problem. We still need to test stuff, but I'll be making sure that this week I'll be making a live where I'll be in fact utilizing the Unreal Engine, testing stuff, you know. So, oh, look at this. Okay. Oh, now I can look up. Okay, this is perfect. This is perfect. I can go down and up. Okay, so I will be doing Unreal stuff. I'll be practicing and putting all the things that I'm learning right now into practice. But not today. I think I'll be wrapping for today. Probably tomorrow. I don't know if I'll do the live stream. If I don't appear tomorrow, then I'll probably be back on Saturday. I usually don't do on weekends, but I'll try to, you know, compensate for the days that I don't do during the week on the weekends when necessary. So yeah, that's basically it. Let's go. Let's make a very nice game to play here. And yeah, see you guys in the next live. Bye bye.